Hello and welcome back to our lessons, our recorded lessons. Okay. Today we are reviewing 2.7, the powers of monomials. Yeah, move my face here. There we go. All right. So as I said in the last video, and maybe the video before that, monomials should be reviewed from Unit 1. We're just diving deeper in Unit 2, okay? All the things we covered, or some of the things we covered in Unit 1, you'll see again multiple times throughout the units. We're just taking a deeper dive to ensure that you understand the concept, okay? All right, so let's get started. Is my pen loaded? Locked and loaded. Yes. All right, here we go. We are doing or covering powers of monomials. I feel like my pen is really, like, can I make it thinner a little bit? Maybe 20 instead of 30. There we go. And then this is pre-algebra. I know some of you put my name long there. That's fine. For me, it's pre-algebra. You're all in my class. So here we go. Powers of monomials. So we covered the rule for dividing monomials. What about when you multiply them? But not multiply them like we've seen in the first monomials worksheet where you have, x to the second times x to the third. In this case, you just add the exponents, right? It's x to the fifth. That's an example of just multiplying monomials. This is multiplying powers of the monomial, which is different. So you should see exponents that are, you should see monomials with exponents, and then you should see that raised to another exponent. When you have that, you multiply the exponents at that, for when you see a power raised to another power, you multiply them together. All right, so, excuse me, again. To raise a monomial to a power, use the power rule. And that rule is to keep the base, multiply, exponents. All right. In this scenario, we have x to the power of a, whatever a is, in parentheses, raised to the power of b. And we don't know what b is. So we keep the base, right, x, and then I would multiply a times, and put a little dot, b, whatever those two things are. Okay? All right, let's try using numerical basis. Using numbers first. We're going to simplify, express your final answers using, again, only positive exponents. Only positive exponents. Only positive. Here we go. So we have 8 raised to the second power in parentheses. And then whatever that answer is, we raise that to the 5th power. Well, we don't want to do that in this scenario. We don't want to we don't want to find the value. We're practicing with the monomials. I know some of you like to raise 8 to the second power, which is 8 times 8, which is 64, and then 64 raised to the 5th power. That's if you're looking for the value of the number, right? How much is it worth? When you think of the word value, think of how much is it worth? What's the value of my home? My home is worth maybe $250,000, right? So when someone's, what's the value of your car? Somebody's car may be worth $20,000. So when you think of the word value, you're thinking of an answer, like you're of a number, a large number, to show the value of that number, right? In this case, we're just simplifying to show the expression, right? I don't need the value of 8 to the second power raised to the fifth power. I don't want the value. I want the expression. What should the expression look like? Because this looks complicated. Okay, so simplifying this expression, 8 stays the same. And then you have 2, you multiply the exponents. 2 times 5 is 10. So it'll be 8 raised to the 10th power. And know this, if you didn't know this before, whatever 8 to the second power is, and then you raise that to the fifth power, I believe the answer, I could be jumping ahead of myself there. The answer should still be the same as 8 to the 10th power, or I could be wrong, because then it's 64th to the fifth power. I could be wrong there. So I'm going to backtrack and not say that. I don't know what is going on when I start recording. I all of a sudden have burps. Okay, so let's do number 2. All right, then we have negative 15 raised to the 6th power, and then whatever that is raised to the 3rd power. So we keep the base. It's going to stay. Is it going to stay negative? Because negative 15, well, we'll find out at the end. So negative 15 raised to the 6th power is even, which means that you'll have double numbers or double negatives, which turn to a positive. But then to the 3rd power would make it odd. So it is going to stay negative. So it's negative 15. And 6 times 3 is 18, sorry. 18. So it's negative 15 to the 18th power, which means that it's going to turn out positive. All right. Then I have, negative, or I have 4 raised to the negative, to the power of negative 2. And then that raised to the power of 2. So 4 is going to stay my base. Oh, we're going to have to move this over a little bit. 4 is going to stay my base. And then 2 times, negative 2 times 2 is negative 4. But remember the direction said positive only. So I know this negative tells me that I need to flip this or invert it. So it's going to be 1 over 4 to the 4th power. I keep everything the same. I just remove the negative by making it a fraction. I'm going to keep saying that so that you remember that. All right, next one we have, 2 to the power of 4, and then that's raised to the power of negative 2. So 2 is going to stay the same, my base 2. And then 4 times negative 2 is negative 8. And then we're going to invert that because there's a negative right there. And that's going to become 1 over 2 to the 8th power. All right. Let's keep going. We have 10 raised to the power of negative 3, and that raised to the power of negative 7. So 10 is going to stay my base. And 2 negatives multiplied together will give me a positive. So 3 times 7 is 21. All right, 3 raised to the power of 3, and then that raised to the power of negative 1. 3 is going to be my base, and 3 times negative 1 is negative 3. Can't leave it as a negative exponent, so that becomes 1 over 3 to the 3rd power. Cool, that was easy. Numerical basis. Variable bases. All right, so variables meaning letters. Letters with exponents. Here we go. We have x raised to the power of 9 and that raised to the power of 3. X is going to be my base, and 9 times 3 is 27. There we go. All right, next one we have a raised to the power of 2. And that raised to the power of 7. So a is going to be my base. Oh, that's a terrible a. Sorry. And 2 times 7 is 14. Okay, easy. We have k raised to the power of 4, and that raised to the power of -5. So k is going to be my base. And 4 times -5 is -20. But we can't leave that negative sign, so it's going to become 1 over k to the 20th. Okay. Here we go. We have cd to the power of 2. And then that raised to the power of 4. So we have, CD Okay, so C in this case is raised to the power of 1, and 1 times 4 would be 4, so C would be 4, and D is raised to the power of 2, and 2 times 4 is 8. Because C, even though we don't see it, because we don't need to put it often, it's a 1, right? So C is raised to the power of 1, and 1 times 4 is 4. That's how I got C to the 4th, D to the 8th. All right. We have M raised to the power of -2, and -2 times 3 is -6, and N raised to the power of 8, and that times 3 is 24. But we have a negative exponent, so we need to rewrite this, and we rewrite this as 1 over m to the 6 times n to the 24th, which will give me n to the 24th over m to the 6. My final answer. All right. Then we have x raised to the power of -4 and y to raised to the power of -2. So x, 2 negatives will give me a positive. 4 times 7 is 28. And y, -2 times -7 is positive 14. There we go. All right. Let's do examples with coefficients, just like yesterday. Let's make sure we've got a lot. So I'm going to go ahead and start talking a little faster as I go down. All right, if you needed to pause, I apologize. Here we go. So examples with coefficients, just like yesterday. Co means more than one, right? That means you have two things that are used together, right? Company, conversation, anything with CO means more than one. Or there's more than, there's more than one. All right, raise the coefficient to the given power, and then simplify the variables with the power rule. So in this scenario, in this situation where there are coefficients, right? There are numbers with variables. It's telling you to raise the coefficient, which is the number, to the power that it's saying, and then apply the rule to the variable, the letter, okay? So 3 raised to the second power, which is 3 times 3, is 9. And then x will still stay x. X to the 7th power times 2 is going to give me 14. Does that make sense? That's what it says. Raise the coefficient to the given power, and then you simplify the variables with the rule. Sorry. All right, here we go. 5 raised to the 3rd power. Oh, I don't have my calculator. Where's my phone? Okay, so we have 5 times 5 is 25, and 25 times 5 is 125. So we have 125 n, and n to the 4th times 3 is 12. There you go. There's a lot of noise in my house. Yes. If it helps you, let me see. I wanted to show you an easier way. I'm just going to redo it with this one, and I apologize. So let me show you this one. I'll show you with these 4, actually. We already know the answer, but let's, if I can go back, I would go back and erase this part, but I can't. I'd have to start all the way over. So we're just going to go back and show you. So what this means is we're doing 3 to the 2nd power times x to the 7th power times 2. And that's how we get 3 to the 2nd power is 9, and x to the 14th. If that helps you to visually see it, if you're one of those people, right? So in this one we have, I'll do it with all of these. We have 5 raised to the 3rd power times n raised to the 4th power, and we have to times that by 3, which will give us 5 times 5 times 5 is 125 n to the 12. Okay, I'm going to do it here with 15 and 16, and then I won't do it anymore. All right, so for 15, we have 10 raised to the 2nd power times x to the 7th, which will multiply the 7 times 2. And that'll give us 10 times 10 is 100. And then x, 7 times 2 is to the 14th power. And then we have 4 raised to the 4th power times w, negative 7 times 4. All right, that will give us 4 times 4 is 8. 8 times 4 is 28, and 28 times 4 is, oof, I don't have my calculator, I left it. Let me use my computer. 28 times 4 is 112. Is it 112? Am I wrong? Sorry, double checking. I feel like that's wrong. 4 times 4, oh, 4 times 4 is 16. 16 times 4 or something. Okay, let's do this. Calculator. So we have clear, using my computer. 4, will it let me raise it to the 4? Times 4 times 4 times 4 is equal to 256. I was way off. Okay, so we have 256 w to the negative 28. 7 times 4 is 28. Oh no, we can't have that as a negative. So we're going to invert w because the exponent is applied to the w. So we have 256 times 1 over w to the 28th, because it's just the negative that makes us write w to the 28th as a fraction. So then we have 256 over w to the 28th. Boom. All right. Let me move on so that I can move a little faster because we got a lot more problems. Yeah. We have 2, 4, 6, 8. 10, 12, 14 more, and I've got like 12 minutes, so 1 minute per problem. All right, I'm not going to write them out anymore like this. I'm assuming that if you need to go back and look to see how I did it, that you go back and look to see how I did it. Here we go. We have 2 to the power of 6. I am using my calculator, just like I'm assuming you are. 2 to the power of 6 is 64. So we have 64. And then p, 2 times 6 is 12. And q, whoa, what is that? It's like a weird A. Q, 5 times is 30. There we go. All right, next one we have, sorry, I didn't mean to zoom in. We have 7, negative 7 times negative 7 is 49. And then you have A, 8 times 2 is 16. B, 3 times 2 is 6. All right. We have 4. 4 times 4 is 16. And then we have C, negative 9 times 2 is negative 18. Times D, 2 times 2 is 4. And we have a negative here, so we have to get rid of that. So this looks like this. It should look like 16 times, we're going to flip C and make it a fraction, 1 over C to the 18th power. Again, I leave the exponent. I just remove the negative by making it a fraction times D to the 4th. And if we just imagine that 16 is a fraction, it's just 16 over 1 and D4 over 1. You multiply straight across. So 16 times 1 times D to the 4th. So it's 16D to the 4th over 1 times C to the 18 times 1 is C to the 18th power. All right. Here we go. Here we have negative 3 to the 3rd power. That's 3 times 3 is 9. Negative 3 times negative 3 is positive 9. And then 9 times 3 is 27. Negative 27. Because we times it by a negative 3. Then we have M. Negative 3 times, or negative 2 times 3 is negative 6. And N to the negative 5. Negative 5 times 3 is negative 15. All right, I need to rewrite these as fractions because they both have negative exponents. So I have negative 27 times 1 over m to the 6th times 1 over n to the 15th. And then if I multiply straight across, I end up with negative 27 on the top and m to the 6th, n to the 15th on the bottom. Yep. All right. Then we have 5 times negative 2, or 5 to the negative, to the power of negative 2, which would be, right, if I rewrote that as 5 negative 2 times 6 times negative 2, I would get, this needs to be written as a fraction, right? So it's 1 over 5 times 1 over 5 times k to the negative 8, which would be 1 over 5 times 1 over 5. I'm just writing it out for you, times 1 over k to the 8th, because I would remove the negative in the exponent. So it would be 1 over 5 times 5 is 25, k to the 8th. Took a minute because we have to write that out, right? Negative exponents means that they are fractions. We can't do the math until it's rewritten as a fraction. Okay, here we go. So we have 2 would be 2 to the negative 4th times a to the negative 20 times b to 2 negatives make a positive to the 8th. All right, I'm going to rewrite this as 1 over 2 to the 4th power times 1 over a to the 20th times b to the 8th. All right, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, So I'm going to have 1, or I'm going to have b on the top. I'm going to multiply b to the 8th. And 2 to the 4th is 16, I said, right? 2 times 2 is 4. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 a to the 20th. All right, sorry. Took me a minute. Which, again, I want you to know that I get when you're doing math problems and there's multiple steps, it may take you a little bit longer, and that's okay, right? The purpose of that is for you to work through it. All right, where am I at? I got 5 minutes to get through all of these. Let's get to it. Here we go. Ooh, tricky, mixed practice. It's trying to make you remember the first worksheet on monomials when you multiply, and I used it up here. I showed you up here. When you multiply them, oh, I erased it. When you have x squared times x to the cube, you add the exponents, right? So down here, it's trying to make you practice those mixed things, because I even see division here too. We know when the quotient rule applies when you are dividing. So there's multiple things going on in each of these problems, which means it's going to take us a little longer, but we're going to get through it one step at a time. Here we go. We have the power rule here, but then after we get our answer here, we multiply it by this. Easy. So we have 6 to the second power, which is 6 times 6 is 36. And we have w. And w, 8 times 2 is 16. So 16, or 36w to the 16th power times 5 to the, with 5w to the 3rd power. And we multiply the coefficients, the numbers, and then we add the exponents. So we have 36 times 5. I had to hit clear on my calculator. 36 times 5 is 180. So I get 180 W, and 16 plus 3 is 19. Boom. Okay. All right, here we go. We have to work on this one first. So we have -4 to the power of 3. I should know that. 4 times 4 times 4 is 64, but it's negative because it's the odd number. 64. A, and 2 times 3 is 6, times 2a to the 7th. Well, we're going to multiply the coefficients, the number. 64 times 2 is 128. Negative, sorry, because of negative 64. And then a, 6 plus 7 is 13. Boom. Okay. All right. Ooh, tricky. So before we do anything, before we do the exponents rules, do we do the exponent rule first? Let me see. Yes, we do what's going on in parentheses first, order of operations, before we take it to the exponents, right? PEMDAS. Parentheses first. Do what's in the parentheses first before you do the exponents. Parentheses first. So 5, we're going to multiply the coefficients. 5 times 3 is 15. And then because the p's are being multiplied, we just add the exponents inside. So 15p to the 4 plus 3 is 7. And then that is in parentheses all to the second power. Now we can do this. So 15 times 15 is 225. And then 7 times 2 is 14. There we go. Bingo. See how it's making us use multiple skills to solve? It's okay. We can do it. All right. Parentheses first. So because these two things are being multiplied, I'm going to add the exponents inside. So I'm going to have x, negative 8 plus 3 will give us a negative 5. Then y, negative 2 plus 9 will give us a positive 7. And all of that raised to the 4th. All right, we can do this. So we have, this will give us x, and negative 5 times 4 is negative 20. And y, 7 times 4 is 28. We have a negative exponent. We can't leave that. So this now becomes 1 over x to the 20 times y to the 28th, which equals y to the 28th over x to the 20. Right? Am I wrong? No. There we go. Let's keep it going. Last 4. Oh, we have division down here. That's okay. We know that we have to divide or subtract the exponents because it's division. And we just divide the coefficients. But before I do that, there's a parentheses with an exponent here. I need to take care of that first before I can divide, okay? All right, so I have, this is going to look like 56k to the 28th. I leave the top, and then I'm going to fix the bottom for us to do the actual math. So negative 2 to the 3rd power is 2 times 2 is 4. 4 times 2 is 8. It's going to be negative 8. And then we have k. And then 8 times 3 is 24. I was about to say 27. 24. Boom. All right. Now we can divide the coefficients. 56 is a factor of 8. Let me go down here so you can see. So 8 can go into 56. Negative 8 can go into 56. Negative 7 times. And then 28 minus 24 is 4. Bingo. All right, here we go. All right, we have the parentheses going on up here, so I need to rewrite this so I can see what to do. So 12 to the power of 2 is, 12 times 12 is 144. Yes, 144. And then c to the 3rd, 3 times 2 is 6. 7 times 2 is 14. Divided by 18. C, 8, D, 10. Cool. Now we can subtract. I'm not sure if 144 is a factor of 18. Let's find out. 144 divided by 18 equals, oh, it is, equals 8. All right, so 144 divided by 18 is 8. Wow. Is 8. And then we subtract the, I'm gonna have to move it over because I see negatives. So we have 8 and C, 6 minus 8 is negative 2. And D, 14 minus 10 is 4. So I'm gonna have to rewrite this one because there can be no negative exponents. So it's gonna look like 8. Let's move this. Oh. 8 times 1 over c to the 2nd power. Remember, the negative just tells us to rewrite it as a fraction. Times d to the 4th. Multiply across. 8 times 1 times d to the 4th is 8d to the 4th over c to the 2nd. All right, last 2. Lots of steps, but we get there. Oh, tricky, tricky. When you're adding monomials, you have to have common exponents in order to combine. They have to be common when you're adding and subtracting. The rules change for every type of math, right? Adding and subtracting have different rules from multiplying, which have different rules from dividing. Okay, so here we go. We first need to do the parentheses. So we're going to rewrite 40 m to the 6 n to the 21st plus, all right, we have 4 to the 3rd power. 4 times 4 is 16. 16 times 4. I don't know why I can't do math in my brain really quick. 64. So we have negative, I'm sorry, it's negative 64. M 2 times 3 is 6, and N 7 times 3 is 21. Oh, look at that. They want us to combine because they are like terms. The exponents are the same for M and the same for N, which means we just combine the numbers and leave the variables the same. So 40 plus a negative 20 or negative 64 would be, my brain's not working properly. It would be 24. Negative 24 m to the 6 n to the 21st. Remember, adding and subtracting monomials means that you can only combine the like terms. If they look alike, then you can combine them. If they don't, you leave them as an equation. If these variables were not the same, the exponents were not the same, I would just left this problem as a whole equation because we can't combine them if they're not the same. All right, but this is my final answer. Here we go. Oh, good, we have both. Okay, so we have 4 times 4. We just did this one. This one's 64. 4 to the 3rd power is 64. And then A, 8 times 3 is 24. And B, 2 times 3 is 6. Minus, all right, 3 to the 2nd power is 9. Then A, 12 times 2 is 24. And B is 6. Good, look at the variables, exponents are the same. That means I can just combine the numbers and leave everything, leave the bases, right? So 64 minus 9 is 55. Yeah. Positive 55. And we leave the bases. A to the 24th, because they're the same. B to the 6th. I think that's right. Yes. There we go. Bingo. All right. So it took us a little time to get to where we needed to be. Lots of different mixed reviews to make sure that you are practicing understanding all of the monomial concepts. The first monomial concept was you only combine like terms. If you have variables that are being added or subtracted with exponents, you can only add or subtract if the exponents are the same, and you don't change the exponent. You just combine the terms. All right. Again, I showed you that right here. Oh, no, that's different. Sorry. If you have x, 2x to the 3rd plus 9x to the 3rd, well, the x to the 3rds are the same. So I can leave the x to the 3rd and just combine 9 plus 2 is 11. Okay, that's with adding. You're just combining like terms. When it comes to multiplying variables, like this one, you add the exponents because the x's are being multiplied. Okay, and then you have division, the quotient rule, where you subtract the exponents. Okay, and then you have the product rule, which is what we covered today, where if you, or not the product rule, is it the product? Powers of monomials. I mean, product means multiply. So that if you have coefficients, or you have equations or problems that are raised, exponents that are raised to another power, that you multiply those exponents together. Okay, lots of different concepts combined into one idea. But again, take your time and you just need to practice. A lot of this is just practice, okay? All right. I will see you in the next video, I hope. Have a great day.